So a big warm welcome, and today what we're going to do with our first webinar is really focus on the South American context. Just to introduce myself, my name is Paul Kemp. I'm a professor of ecological engineering at the University of Southampton, and I'm also the director of the International Centre for Eco-Hydraulic Research. So what is the SHAASAN network all about? This network that's focusing on sustainable hydropower for Africa, Asia and South America. Well, basically we're focusing on some key challenges, and it's worth just reminding ourselves what these are. First of all, when we think about tropical and the subtropical, neotropical and southern temperate rivers in Africa, Asia and South America, we're talking about rivers such as the Amazon, the Congo, the Mekong, that can maintain huge amounts of species richness and endemism. And this, of course, relates to the massive amount of variability in terms of the physical and chemical habitat that is created in those particular rivers. But there's many other types of river too. There's many small rivers that are all important from the perspective of ecosystem services. The other thing to think about is that the fresh waters in these regions are among the most degraded and threatened of all ecosystems on the planet. And there's many high-level UN reports, for example, that have evidenced that statement. The other key point is that people depend on these rivers. In many of the developing regions, the fish that are provided, the fish that maintain those fisheries, are the main source of local economies, the income for the people, and also a major source of protein for these low-income people that depend upon them. And also superimposed upon this, we have regions that are experiencing massive hydropower development. And this leads to conflict and controversy. And in many cases, we're dealing with development and the creation of biodiversity hotspots. So on the one hand, hydropower is a fantastic thing in terms of improving the quality of life for humans and providing electricity in many cases to poor rural communities. On the other side, it can have huge and substantial impacts on freshwater ecosystems that people also depend upon. So the aims of the SHAASAN network are overall to improve the sustainability of hydropower for the future, thinking about the next generation of hydropower and how that can be developed to be more environmentally sustainable and sensitive. We aim to protect fisheries on which low-income fishing communities in developing nations depend for food security, for their economy and for their culture. And in particular, from the social science perspective, fisheries can be hugely important for women and migrant workforce. We're going to focus on how we might advance environmental impact mitigation technology and develop more sustainable operations and planning practices. And we're taking an approach of thinking from the cradle through to the grave in terms of reducing environmental impacts during the planning and then construction and operation, right through to the end-of-life decommissioning of these hydropower facilities. But ultimately, what we're trying to do is build up a network where we can disseminate knowledge and build research capability to be able to transfer information and best practice and experience from the global north to the south and vice versa, from the south to the north, but also between nations in the south, from Chile in South America through to Africa and Asia, such as Cambodia and Vietnam. What we're going to do in this network is we're going to have in the first year, 2021, online webinars. This is the first, focusing on South America. We will then have a second webinar that is focusing on Asia, and that will be hosted by the Institute of Hydroecology in Wuhan in China. And then we will have the third webinar based in Africa. In 2022, we are hoping to leave our desks and have some physical events, physical meetings, first of all in South America, in Colombia, and then we'll move over to Asia. In 2023, we hope the network is becoming sufficient through sponsorship and finding other funding sources, and we'll hold our first event in 23 in Africa. What we're aiming to do is not only develop the research agenda and create new exciting research programs in this area, but also develop information that was of use to policymakers and governments. So overall, we'll be producing a lot of documents that range from public outreach and dissemination through to policy briefs, and then, of course, research papers. Just want to emphasize that we're a very diverse and global team with people representing institutions and industry right throughout South America, Africa, and Asia. So hopefully you'll be meeting a lot of these people during the course of the SHAASAN network and hearing from them in various different webinars and in public meetings. I'd like to mention and give special thanks to the Global Challenge Research Fund that has enabled us to develop this network. This has provided the seed funding to get it off the ground and will provide us funding for the next couple of years. Hopefully we'll be able to develop this further, involve more people and secure more funding for the future. If you'd like to find out any more about the network, please look at the website that is provided at the bottom of this slide. So finally, for me, just to introduce our key speakers today, we have Hector Vera Alcaraz, who is the lead of the network, and he's going to be talking from a Paraguayan experience about sustainable hydropower in the La Plata Basin. Then we have Luz Jimenez Segura and Scott Winton, who will be talking about sustainable hydropower in the Andes and particularly focusing on Colombia. Then we have Oscar Link, who's going to give an engineer's perspective about the development of sustainable hydropower in Chile. And finally, we're going to hear an industry perspective from Raquel Fontes, who is a representative of Samigi, which is one of the largest hydropower generators and distributors of electricity in Brazil. So we've got a really great team and some really great presentations for you today. So with that, I'd just like to hand over very quickly to Jenny Knight, who's going to give some ground rules about how long the presentations are and also what we are expected to do in terms of turning our screens off when people are talking and make sure the microphones are on mute. Jenny.
Good afternoon, everybody. Thank you very much, Paul. Very quickly, as most people have done, you're already on mute and the screens are off currently, and whilst presentations are going on, we've asked if people are able to put questions into the chat, and potentially later we can have our cameras turned on for the question time. But in the meantime, cameras off, microphones on, and just enjoy the presentations. We'll pass you over to our first presenter. Thank you very much, Hector.
Hello, good morning. Good morning for the people here in South America. I'm going to start my presentation. Please, Jenny, can you say if you can hear me? Is everything okay?
Yes, we can hear you well.
Yes. Well, as Paul and Jenny said, my name is Hector. I live and work in Paraguay, South America, for the Ministry of the Environment and Sustainable Development, and also in the National University of Concepcion. Today, I'm going to present a review of the state of fish biodiversity and hydropower dam context, focusing in La Plata and in Paraguay. First of all, South America, one of the members of this network, joined with Africa and Asia. And South America, we got 3 large basins. The La Plata Basin. Hello?
Hector, can I just check, are you expecting to be sharing your screen at this point?
Yes, I'm doing the presentation now.
I can't see the screen. I don't know if this is the case for other people.
Okay.
Yes, I don't see.
I don't see either.
Okay, I'm sorry. I failed here. Just start again. Can you see now the presentation?
If you go in the top right hand, Hector, you can see the white box with the arrow.
Is present now? Sorry.
No.
No, it's not presenting. I can't see anything.
Okay.
Héctor, al lado del micrófono hay una flecha para compartir pantalla.
Aquí estoy. Entré.
Ahí sí.
Ahora sí. Hello. Okay now?
Yes, this is great.
Can you see the presentation now?
Yeah, so you just need to go into present. That's perfect. Thank you.
Okay. Well, I'm from the National Museum of Natural History from Paraguay and also in the National University of Asunción. My name is Héctor Vera Alcaraz. My presentation going to focus on in a review of the South American context and making the presentation from La Plata Basin and Paraguay. South America, one of the members of this network with Africa and Asia, we can see in the map. In the hydrographic context, we can see the La Plata Basin, which is the second largest basin in this continent. Now we got a close look to this basin. I'm going to present the political context. 5 countries are distributed in this basin: Bolivia, Paraguay, Brazil, Argentina, and Uruguay. I'm going to present some aspects of the hydrological context. I'm going to focus on in this region, in the Paraná River. And we got some data about the stream flow or fluvial discharge in this basin. We can see in the left that the discharge is about 1,000 in the upper reaches in Bolivia and Brazil border, and can reach near to 20,000 in some parts of the Paraná River in the Paraguay and Argentinian border. So why this happened, we can explain by the altitude and also by the rainfall pattern. We see in the dark gray region that this part of the map has the greater rainfall pattern. And we see also on the left of the map that the Bolivia, Argentina, and Paraguay border has the lesser rainfall pattern. So focusing in the region with the highest amount of fluvial discharge, we see the Paraná River and also the Uruguay River. In the context of the hydroelectric dams, we can see some of the largest or highest potential of power in the generation of electricity. So now in the fish biodiversity context, we can mention 5 categories of main threats related to the biodiversity. But I'm going to focus on 3 of them, which might be most related to dam construction, which is the flow modification, habitat degradation, and the species invasion. An example in the Upper Paraná River, the Itaipu Dam in Brazil and Paraguay, we see the picture there. We got as an example of a strong modification of the habitat in the pre-dam construction, the Saltos del Guairá or Guairá Falls or Sete Quedas Falls. And we see the modification now in the post-dam construction where the falls are totally flooded. Some examples that also describes the impacts to the fisheries are presented by Agostino et al. And they mention that the impact is also longitudinally to the river and transversally to the river, impacting the fish structure. For example, post-dam construction, we can see that the community structure in the littoral, pelagic, and deep community moves to another structure. It also happens in the abundance and in species richness. Another example in the pre-dam and post-dam construction is the target species which are affected. We see in the first graphic bar that most species abundant are large migratory species as the pacu and dorado and surubi. We see that in the post-dam construction totally moves to smaller species. So we got an impact in the community structure also. Another example of the impacts of the dams, which can illustrate the example in the La Plata Basin, is the Yacyretá Dam in the lower Paraná River. We see a picture of this dam, and we got an example related by Oldani and Baygun that there are some strategies to mitigate the impacts are the fish passage and fish passage mechanisms as the elevator. For example, we see that in this region in Paraguay and Argentina, the target species for this fish passage were migratory species as the Prochilodus lineatus, but the most benefited species which smaller species as the Pimelodus clarias species in the left of the graph. Another example done by Makrakis and collaborators is the fish passage by ladders, which also present some problems in contrasting small and larger species. We see that the upstream movement are most favored, contrasting with the descending movement across the barrier. For example, I got this picture of these two species, South American, the smaller species, which is the size of a foot, which most favored to the passage ascending and descending, contrasting with larger migratory species as the Leporinus, which see in this picture, which are most favored just in the upstream movement. Another consequences or explanation for why this happens with the barriers, we can see in the planktonic fish eggs and larvae of fishes. For example, in the Tocantins River, this is another example from another basin presented by Agostino and collaborator, but also with ladder fish passage. We can see that in the pre-dam construction, the diversity of eggs and larvae, which distributed across the ecosystem. But in the post-dam construction, we see that totally the reservoir and dam are diminished in this diversity. This is another consequence. So, just to close in my presentation, in the fish biodiversity context, we see that the protection of freshwater biodiversity is the ultimate conservation challenge. That's because it requires so large scope of control. for example, across the basin, the land, the infrastructure, the people. So that's why the conservation of fish biodiversity is so complex. This is presented by Dujan and collaborators. And I got another commentary also from Agostino and collaborator that the actions to mitigate dams, considering it, the main focus is considering fish passage, fishery, and stocking. And the results of these actions are not always as good as we want. For example, in the fisheries, we see that the species large migratory are not favored. Also, we got another practice from the hydroelectric dam, which is the stocking, which foreign species or invasive species as the carp, the tucunaré, or the tilapias, and focusing in the network, which is in the low-income fishing communities. We see that the target species are the large migratory and endemic species, as the pacu or Piaractus mesopotamicus. So we propose the network to disseminate the knowledge and the research capability of the region by doing a strong network with people from Africa, Asia, and South America to start sharing our experiences and help to develop the conservation of these fishes. So thank you for your attention. And that's all.
Thank you very much, Hector. That was a great opening presentation. Jenny, I don't think we have questions in the chat as yet.
No, I've not seen any questions as yet.
So we've got time for people to ask questions. Do we have any questions for Hector, please? So if you're not used to using Teams, there is a little face with a hand, so you can put your hand up. That's on the screen. Or, so we do have some questions. So Paolo, please.
Hi, Hector. Thank you for your presentation. It was a great one. What's the current scenario for new power plants in Paraguay? Are you expecting a new boom or new big dams or reservoirs being constructed in the near future?
Yes, there is a plan for doing small dams just for the energy consumption in the country, not for exporting the energy as we do with the Itaipu and the Yacyretá Dam, which mostly is the energy is sold to our neighbors' countries. So we got a plan for more dams, small dams in the Paraguay River, and also we got another dam in the Paraná River.
Thank you, Paolo, for that question. Scott, we have hands up from you.
Hi, yeah, thanks, Paul. Hector, thanks for the great presentation. I was just interested because you were mentioning the Yacyretá Dam. It was one that was, I was doing a synthesis project a couple of years ago, trying to understand whether tropical reservoirs stratify. And Yacyretá came up as an interesting case as possibly one that might not based on its discharge and dimensions. But I could never find any actual depth profiles or any information about that water body. I don't know if you happen to know anything about the limnology or the mixing regime of that dam, or have a contact maybe you could connect me with?
Yes. I got some information in in the physiology of the river, but from the dam it's difficult. We cannot find much information in the academic area. Much of the information are how to say presentations or just works from the energy dam itself. So it's difficult to find information in the academic area. That is true.
Thank you, Scott, for that question, and an obvious example there where information and knowledge transfer would be good. Do we've still got time for more questions for Hector? Okay, last chance. Okay, well, in that case, thank you very much, Hector. It was a great presentation, and we'll move on to our next speaker, who is Luz and Scott. Are you ready?
Yes. Okay, are you seeing my screen?
Yes, we can see your screen. You just need to put it. That's it. Perfect. Thank you.
Okay, wait a minute, please. Wait. I will turn off. My camera is turned off. Is my camera turned off?
Yeah, your camera's off, Luz.
Okay, thank you. Okay, hi everybody. Good morning and good afternoon to all the people in this webinar. I'm Luz Jimenez, and my partner is Scott Winton. Now, we are going to show you, we are going to show you some advances of the shared strategy, a strategy built by different institutions and financed by a seed found from the Swiss Latin American Center of the University of Gallen to develop a strategy that helps in the hydropower planning in the Andes countries. Around the world, it's recognized that reservoirs with riverbeds modify the hydrological cycle, retain sediments, and eliminate biological processes associated with the dispersion of aquatic biota along the river channel. You can see here the hydropower planning around the world. Do you think this is eco-friendly and sustainable? And what about the Andes region? Our strategy, the shared strategy, is to bring together three groups of actors within the hydropower business at the same table: hydropower companies, environmental authorities, and non-governmental organization with academic researchers. Our main goal is to understand how the reservoirs in the Andean rivers modify the conditions of the water, the ecosystem functioning, and the ecosystem services that they provide as a fundamental input in the planning of hydroelectric development. Our specific objectives are to describe how the reservoirs change the conditions of the water in the Andean rivers, how they change the structure of the aquatic communities in the Andean rivers and reservoirs, and contribute to decision-making associated with the watershed management in the Andes countries. Then, let's talk about the Colombian case. For those who don't know, Colombia is a beautiful country located in the southwest of South America. We have short rivers with strong elevation gradients and a large amount of sediment. Our rivers are in the top 10 of the river basins with the highest production of water per square meter. Most of the rivers have a monomodal hydrological regime, and only the Magdalena River has a bimodal regime. In the Colombian rivers, 610 freshwater fish species inhabit with high endemism. assemblage of species are specific to each aquatic system. Rivers, streams, or lakes in interaction with elevation. The highest species richness is found in the lowlands, and 20% of them are important in artisanal fisheries. The Andean topography and the power water production of the Colombian rivers has favored the use of water to generate energy. There are 35 reservoirs that generate more than 100 megawatts and a little more than 255 small reservoirs with lower generation capacities. According to the experts, only 20% of the hydropower generation capacity of Colombia has been used. Based on the limnological and hydrobiological monitoring required by the environmentally sensitive authority to hydropower companies, the authority has constructed a monitoring network of the basins where are the reservoirs. So we group the National Environmentally Sensing Authority, Empresas Públicas de Medellín, one of the 5 hydropower companies in the country, and the University of Antioquia, the Swiss Federal Institute of Technology in Zurich, and the Nature Conservancy to participate in the shared strategy, taking as a starting point the information that comes from the monitoring carried by the power companies. With this team, a group of specialists, including biologists, limnologists, chemical limnologists, and engineers. Scott.
All right, Luz, thank you so much for the introduction, and thanks, Paul, for having us in this webinar. So I'm going to talk a little bit about the water chemistry, the water condition or water quality side of what we've learned from these Colombian dams. So this ANLA database we've discovered is unique, at least in the Andes, if not all of South America, that there's a central government repository for monitoring data for such a large pool, like a national level pool of hydropower projects. And we were really interested in leveraging this relationship with ANLA and this database to see what we could learn about how these dams change the conditions of water and the water surrounding the dams. So we looked, there's a lot of data, different types of data in this database, including fauna, like things like fish, and a lot of different chemical and physical parameters. We wanted to focus at first on a few key parameters that we think are really fundamental. So how dams alter thermal regimes, whether dams are creating hypoxia in the downstream waters. These two processes stem from this process of reservoir stratification, where you have warm water on the surface that's less dense, and it becomes difficult to mix with deep water. And so you can accumulate cold, deoxygenated water down in the deep waters of your reservoir, and then if those end up downstream, it can cause problems for life cycles of fish or other organisms. And so we wanted to assess whether these dams are likely to stratify or not, and then also whether the dams are trapping out suspended sediments, because water clarity and availability of organic particles is also an important kind of constraint on biota. So first we have this kind of big data cleaning process. So the data from ANLA comes in the form of these GDB files, and then also these kind of multi-100-page PDFs that are produced by environmental consulting firms who actually do the monitoring. And so it's an enormous amount of information, and then you have to understand from that information which data points are useful for kind of coming up with metrics for how the different dams function. So there's going to be monitoring stations upstream of the dams, downstream of the dams. But depending on where actually the turbine outtakes are, so that's where the turbinated water goes, that's where you expect kind of problems with oxygen and temperature. You have to figure out which points in the river will actually be affected by that, and then where you'll have loss of suspended solids, which would be just affected by the dam wall itself. And once we went through all that process, we could compare kind of upstream conditions as a reference to downstream conditions. For the question of stratification, we use this metric called densitometric Froude number, which is just based on the aspect ratio of the reservoir and the residence time, hydrologic residence time. And anything below 1 should be stratifying. Anything below 0.3 should be strongly stratifying. And then essentially all the reservoirs we had sufficient data for to calculate this metric fall into a strongly stratifying category. So there's clearly the potential for stratifying reservoirs with hypoxic, deep water, causing problems downstream. When we actually look at the data, looking across projects, I'll start with one example, the Ura reservoir, which is really a nice one because it actually has monthly monitoring data. So we have can look at every month of the year. This is just the most recent year of complete data, 2018. But you can see on the left, this is upstream conditions for dissolved oxygen on top and temperature below. And then between the dashed lines is the reservoir, surface, kind of middle waters and bottom waters. And then downstream, progressively downstream below the outtakes going down. So you can see with oxygen, there's a hypoxic hypolimnion, as they call it, the deep waters. And then some of that hypoxic water is passed downstream, though you can see recovery. So there's reoxygenation and tributaries coming in that are restoring the oxygen. But persistent throughout the year, you have less oxygen downstream than upstream, up to 2 or 3 parts per million loss. And with temperature, there's more of a seasonal pattern. So you have this water in the deep part of the reservoir that's very cold. And so downstream, there's this it's much more homogeneous. There's this tight range of temperatures compared to the upstream river, which is showing more of the natural seasonal pattern. And so in the seasonally, you have either water much colder downstream or water much warmer downstream. Doing the same kind of analysis across all the projects for which we had sufficient data. So every point here is a month, and then the projects are lined up along the bottom of the different dams. We found that the kind of changes to thermal regimes were pretty ubiquitous, especially warm water pollution. So there's not really most dams, at least sometimes of the year, are doing kind of surface releases where they're releasing the warmest water. So the water's piling up in the reservoir, it's heating up in the sun, and then getting released downstream. What's a bit more rare is this cold water pollution. So this is associated with deep water discharge. And what was interesting is these 4 projects, Ura, Quimbo, Sogamoso, Prado, that had cold water pollution were the same 4 projects that also showed hypoxia and downstream. So this is a clear indicator that there's kind of the intakes for turbination or below the thermocline, below the oxycline, and kind of passing water that's not great for fish or other organisms downstream. If you go to the next slide, Luz, that shows the oxygen results.
Are you seeing?
Yeah, there we go. It's just a little bit delayed. Yeah, so the same 4, and these thresholds we drew are somewhat arbitrary. This is just the delta, so the change from upstream to downstream. But the bigger the change you have, the more likely you are to cross some sort of threshold that the ecosystem or the biota will respond to. Finally, the kind of loss of suspended solids, we looked at this in terms of percentage loss, since the numbers are span several orders of magnitude. And this we found also to be somewhat ubiquitous among the projects. So most of the there's a bit of a lag, I think, in the slide changing, but most of the projects, maybe like the majority, showed loss of suspended solids of greater than 50%, and some kind of 99%. There's one exception, Porce 3, which actually had more suspended solids downstream, and that's a function of the downstream rivers. There's a big illegal gold mining or unregulated informal gold mining area, and so there's huge amounts of sediment being produced, like entering the river there. But mostly their projects show loss of suspended solids in quite severe ones. So just to summarize, so we found that most, if not all, the reservoirs in Colombia stratify, and there's changes in thermal regimes, changes in oxygen availability downstream associated with these dams are kind of specific to a few projects. So some seem to not suffer from this. Loss of suspended solids is also quite ubiquitous.
Hi, Scott. You got just under 3 minutes left.
Yep. So I'm going to pass this back to Luz, who will.
Okay.
The idea is we want to talk about, understand what this means for fish. So
okay.
I leave it for Luz.
Thank you. How might this water quality change described by Scott impact on fish? Then to identify if there are changes in the structure of the aquatic communities in Colombian rivers, with the reservoirs, we use data of one of the 7 reservoirs that have long-term monitoring, the reservoir Porcetres. This reservoir is located 500 meters from the elevation. Its area of direct influences, it doesn't have a lateral footprint, and it has been generating energy for 10 years. And the Empresas Públicas of Medellin provide data from fish assemblages before and after reservoir formation. In this map, you can see sample sites downstream and in the dam and in the creeks and in the reservoir. In this figure, you see the ordination of the fish assemblage in each aquatic system before and after the dam. After 10 years of isolation because of the dam, there are new assemblages: reservoir, isolated porous channel, and the increase of similarity and of the creeks assemblage. Also, using the data provided by the national authority, we found the presence of 23 non-native species. In most of the analyzed reservoirs, the presence of non-native species are reported. Now, we consider the cumulative impacts of the reservoirs throughout the basin in terms of changes in water condition and the water assemblage along the fluvial network, and their impacts accumulated by other conflicts generated by human activities in the Colombian basins. Finally, we are in the third phase of sharing, in which we contribute in the planning of the hydroelectric development with the environmental authority. We have held meetings with different target groups to publicize our progress, and finally, to be able to contribute to inform decision-making so that we can have a sustainable hydropower in the basins. Our next steps to advance in the strategy with other Andean countries and design and apply research proposal to carry out the share strategy in all South American countries, and now, if we can do it around the world inside the SHASAAN strategy, looking for potential funds. Thank you very much. Here there are our emails. If you are interested, contact us after this meeting.
Thank you very much. Yeah, thank you very much, Luz and Scott. We have time for questions. Paolo.
Thank you, Luz and Scott, for the presentation. Really nice one. Luz, I have a question regarding some strategies that Colombia has in terms of trying to preserve, to conserve biodiversity. Is there any national plan in Colombia for keeping some rivers non-regulated, considering all these impacts you have described?
Yes, we are looking for this figure of conservation, but there are another strategies to preserve fish and rivers in our country. Many of them are focused in conserving or preserving river characteristics, some river characteristics, in order to keep their food web functioning. But there are different management strategies developed by fishers, developed by authorities, developed by hydropower companies, and there is a lot of people working on that. Then we made a review on those management strategies for one of the more important basin in our country, the Magdalena Basin, and there is a lot of strategies to keep our rivers free and health. But not all of this strategy are according the economic interest of some other companies, different of hydropower companies. There is some industries wanted to recover the navigation of the river, and there is many changes. Here we list some of the current management by hydropower companies, and most of them are developed with by each hydropower company with the with the national authority, the ANLA.
Thank you very much, Luz, and thank you, Paolo, for the question. We've got another question from Hector.
Hello, Luz and Scott. Thank you for your presentation. It was nice to see how the physicochemical modifications in dams are impacting fisheries. I wonder, as in the presentation was mentioned, that it was benefited by non-native or exotic species. I wonder, what about the native species, which is natural from quiet or environments? Do they were benefited or not in this?
Yes, in the reservoir assemblage, we found most of the biomass are from non-native species. However, in the creeks flowing to the reservoir are some rivers flowing to the reservoir. There is the habitat for native species. But some of these species that are migratory, that made short migration, they became isolated. And recent studies we have done in the last year, we found that there been a change in the diversity, genomic diversity in the population of Brickonhenny, a Brickonid species in the Andes that made short migrations from the main river to the tributaries to the main river.
Thank you very much for that question. We've got two more questions. We can do it quite quickly, please. Andre and then Yuri.
Okay, thank you, Paul. Thanks, Luz and Scott. My question could be also to Hector, is regarding the public perspective of the hydropower plants, especially now that we have a dry season in the south, especially in Brazil. All the reservoir levels are quite low, and people kind of change a little bit the perspective of the importance of reservoirs and hydropower plants due to this drought season. And I was wondering whether that could fluctuate a little bit the public perspective of the importance, disregarding all the problems of the reservoirs in general.
Okay, there is, thank you. We have a little problem, because as Hector talks to the Paraná Basin, the strategy is changing because hydro dams have a lot of conflicts, environmental conflicts. Then recent news of the hydropower development is focused on little hydropower dams. Then it's gonna be the same, that this will be occur in the Paraná Basin. All the hydropower development is gonna be focused in little dams and dispersed along the headwaters. And maybe we are not by now focused in what changes in these areas, because the fish species are very they don't move, they don't disperse long distances. Then maybe we have different questions in these areas, in the headwaters in the Andes.
Thank you.
Thanks to you.
Sorry, thank you very much, Luz. And if Yuri, if we could just keep the question and Luz the response quite brief.
Okay, thank you, Luz and Scott, for the presentation. I just would like to ask if you experience fish mortality downstream from dams in Colombia because due to low oxygen, and if so, how companies manage that?
Yes, that downstream mortalities is a conflict we detect, not in all the dams. Some dams, like I don't remember the name. Maybe Scott, you know, do remember the name? Is this is Anshikaya. In Shikaya, we have big mortality downstream the dam, and there are another things that maybe can generate mortality of fish, because most of the dams generate by hydropicking. They change rapidly the water level downstream the river. Then some fishes keep trapped in the lateral border in the rivers. Then the companies have contracted a lot of people that is waiting when the river gets down and go to those ponds in the lateral river to rescue all the species, all the fishes, and to put it on again inside the main channel. But there is a fact that there is another mortalities associated with changes in the water, in the oxygen dissolved in the reservoir. And the hydropower companies are trying to manage this question with some injection of oxygen in the reservoir.
So maybe I can just add something really quickly, if that's okay. So I think the thing with oxygen, it's not causing like mass mortality events. It's more that it means there's just less habitat available. So the downstream of the dam area becomes like some fish can't tolerate the oxygen levels for sometimes. When you have like mass mortality, it's usually associated with an acute kind of like maintenance event where they drain all the water out of the reservoir to do some sort of repairs or do some big sediment flushing event. And this is associated with like, you know, big die off of fish downstream because it's some kind of operation that's not like normal operations of the dam.
Thank you very much, Luz and Scott. Thank you also for some great questions. So now moving on to our next speaker, could I ask Oscar to load his slides and give a presentation?
Thank you very much.
Perspective.
All right. Can you see the presentation, Paul? Yeah.
Yeah, that's great.
It's great. Okay. So welcome everyone to my presentation today. Thanks to the organizers, Paul and Hector of this SHAASAN network for inviting me to collaborate as part of the group. So today I will present briefly the Chilean context in hydropower development issues, and then I will focus on connectivity and fish injury due to hydropower plants. This work was done in the last years in a collaborative way with my colleague Evelyn Habit, who is also here in the chat. She is the ichthyologist of the group, and if you have some specific questions about the Chilean native fishes, she will answer you better than me. I'm a civil engineer specialized in river engineering. So the outline of my presentation is composed of 3 main points. In the introduction, I will present the Chilean context. Next, I will focus on 2 of the most evident and important issues and the solutions we have for fragmentations through the fishways, and the problem of fish injury and mortality due to the passage through turbines, and the possibility that we have to implement barriers. So the available hydropower in Chile is important. In a study from 2015, the Chilean government detected about 1,000 new sites where the available hydropower completed roughly 6 gigawatts that can be produced in the near future. If we look here at this graphic, we have the number of sites according to their available capacity. And rapidly, you see this is a logarithmic scale in the x-axis. So we have only very few projects with high power capacity, but we have an important number, around 900 sites with available power around 0.1 and 50 megawatts. So we expect that the hydropower boom that we are actually starting to see in Chile medium hydropower capacities. So the big hydropower plants were already constructed in the past, and we only have between 2 and 10 sites in Chile where these new dams could be built, but actually due to a number of environmental and social issues, it's not expected that they will be built in the near future. So the boom is expected to occur with projects around 50 megawatts. And the distribution of these projects in the territory is shown here. In the first figure, we have the Chilean territory, and we see the red dots are the existing hydropower plants. In blue, you see the Andean mountain chain. In yellow, you see the Central Depression, and in green, we have the coastal plain. So the main location of our plants is the Piedmont of the Andes. And in this figure here, you see the projection, the expected scenario, if all the available hydropower would be constructed. And the change in the situation, the actual situation would be from the current 140 plants operating with a capacity of 6.6 gigawatts, a change to roughly 1,500 power plants operating with roughly 19 gigawatts. So basically 3 times more power would imply 10 times more plants. And we are rapidly going to the scenario in the right figure. With such amount of power plants, we are impacting one of the biodiversity hotspots in the world. Here you see this is central Chile, where our hydropower projects are mainly planned. In that region of central Chile, we have some 15 basins. We are starting from here, from the Aconcagua River. This is the basin number 6 here. It's around the main city of Santiago. And we have a very small number of freshwater fish species in Chile compared to Colombia. We saw already in the presentation by Luz that they have around 1,600 native fish species. In Chile, we count roughly 45, and 33 of them are located in this area where we expect the hydropower development. So in terms of numbers of species, in Chile, we have a reduced number compared to the tropical regions. And our fishes are mainly small-bodied. Here I present some pictures of our species. Most of them don't reach the 15 centimeters when adults. So we are dealing here with small-bodied fish. In this scenario, we developed a study trying to cross the information about the location of the fish species presence in the different basins of central Chile, together with the location of the planned hydropower plants, in order to see when it would be necessary to propose, to find mitigation technologies, mitigation strategies. And we found basically that in 15% of the planned projects, no mitigations for fish connectivity would be required, because those projects are located at altitudes where native fish are not found or are not expected to be found. Also, we found that about 35% of the planned projects required solutions for connectivity that might be feasible because the number of exposed species in those sites are relatively small, and it's the same assemblage of fishes that is repeated in a number of projects. So basically, with one solution, a multi-specific fishway, for instance, we would provide a mitigation for 35 of the projects. And in about the half of the projects, 50%, the requested solution would be very site-specific and thus much more challenging. So now we are trying to provide more antecedents and solutions for these 35% of the planned projects. In terms of the fragmentations, this is one of the important problems caused by hydropower plants. We have here illustrated in this figure the natural scenario, where we have some waterfalls that were fragmented naturally, some of the river basins in the territory of central Chile. In 2018, the hydropower projects were fragmenting most of the river basins. And the expected scenario in 2050 is that we will have the whole the central Chilean basins fragmented by these hydropower dams. So one possibility to mitigate this impact of fragmentation is to provide connectivity through fishways. Fishways have been developed mainly thinking on salmonids in the northern hemisphere, but now we have the problem or the challenge that we need to provide fishways for such small-bodied fishes, and also the fishways that are required might be multi-specific. So from our 33 species in central Chile, we have some that are anguilliform, others are subcarangiforms, and other group is carangiform, which means that they exhibit different swimming modes that have been investigated in the laboratory. And of course, we found a big diversity in terms of the swimming styles and motivation of the different species, which makes the problem of providing a multi-specific fishway even more difficult. Here you see this video is still running, and this Trichomicterus is just lying on the surface, while in few seconds he will start to swim again. So it's not a real tactical swimming mode. and it's really hard to find how to motivate such a fish to pass a given fishway. Differently to Basilictis, for instance.
Okay, we have 3 minutes remaining.
Okay. Where you see that the reotactical swimming mode is perfectly following the theory. So we have developed some guidelines for fishway design for those species that exhibit a reotactic swimming mode already. And we have also studied the behavior of fishes interacting with turbulence, with vortices, like the wake vortex after a cylinder. And we see that some of the species adopt a Karman gating-like swimming mode, such as the Basilictis here in the upper video, as you see, tuning the swimming frequency with the vortex shedding frequency. And combining this fundamental knowledge about the swimming mode of the species and also doing some preliminary tests in the laboratory, we are working towards a prototype fishway. Here in the video, you see a flume in the laboratory. This is 2 meters in width, and you see that with a configuration of lateral baffles, we are able to motivate this Trichomicterus here through the bottom, following some surface waves that are forming in the wake of these baffles. So this could be a possible configuration for a multi-specific fishway in the Chilean context of the small-bodied fishes. Very briefly, I have 2 slides to just mention another important issue, which is the fish injury and mortality due to the passage of the fishes through the turbines. We have, of course, available in the market already a number of fish-friendly turbines and the possibility to build physical barriers like screens. But for small fishes in such hydropower plants like those shown in the bottom of the figure, which are examples of central Chile, we face the difficulty that screens would need to be much finer than this in the picture, producing important heat losses and energy losses at the end. So this is not economically feasible, and thus we are starting to look at non-physical barriers like stroboscopic lights and bubble curtains that would be able to deter fish from entering the water intakes of turbines, avoiding then the fish passage through the turbines. These technologies need to be tested still for the small-bodied fishes in these regions. So take-home messages to finalize. Strategies to set priorities to increase the efficacy of protection actions are needed because of this hydropower boom that implies hundreds, if not thousands, of new projects. So we need to set priorities in order to be more efficient with our research. Second, small-bodied fishes challenge existing fishway technologies, and therefore particular solutions need to be developed. And finally, the development of non-physical barriers to avoid fish passing through turbines, especially small-bodied fishes, is an emergent topic that will be developed in the next years. Thank you very much for your attention.
Thank you, Oscar. That was a great presentation and very interesting. Jenny, I think we might have had a question in the chat. Is it possible to ask that question? We've got time for just one question, I'm afraid, at this point. Jenny, if you're there, you're on mute. Okay, so looking at this, what I can see is there is a question from Alex, and it's asking Oscar, do you think that in Chile there will be a boom in the hydropower within the next 5 years, considering that actually there's a current boom in solar and wind power generation, which have state support and are much easier to get approved in the environmental evaluation and the world trend in green energy?
Yes, I think modes of energy generations are not excluded. We have a high growth in the energy sector, and because the intermittency of solar and wind power, I think hydropower will still remain very important for energy generation, energy production, especially nowadays where we are starting to see a boom also in the green hydrogen production. So in terms of this energy system, I would expect that all the projects, the solar, wind, and hydropower projects will be developed sooner or later. Yeah. Brilliant.
Thanks a lot, Oscar. I'm going to ask our next speaker now, Raquel, to come on. But Oscar, in the meantime, there are several questions now popping up to you in the chat. If you're able to respond to those, that would be really interesting and useful. Sure. Okay, so our final speaker today is going to give an industry's perspective from Brazil, and that's Raquel. Welcome, Raquel, and really interested to hear about your experience from the SAMIGI perspective.
Thank you very much, Paul and Andrew, for the invitation to join SHAASAN network and for the opportunity to present here in this webinar. I work I'm a biologist, and I have been working in SAMIGI for 15 years. And my presentation is so many fish, so many problems, but well, problems for whom? For us or for the fish, right? Let's see. Brazil is considered a mega diverse country by Conservation International, and we host more than 3,500 of freshwater fish. Just to give an idea, the tropical ecology is the periodic published by Brazilian Society of Ecology, and in 2003, in its first volume, we can find some papers describing new species, and to today we can find papers and papers. We find this kind of paper in all volumes of this journal. So this is our potential to discover new species, and we don't have any prediction to stop it, right? Also, in our rivers, we have many hydropowers. Our energy matrix, mainly from hydraulic sources, corresponding to 62%, as you can see here. Most of this energy are generated by large hydropower, and we have, just to close this, we have 219 large hydropower dams, but we have lots of small hydropower. So all these hydropower are spread out in several watersheds with different fish diversity that needs to coexist with civil structure variability and modes of operation, right? So we have many challenges to prevent and mitigate impacts. And it has become increasingly evident that some of those impacts are not possible to mitigate properly. And this is a great concern, right? What to do? So I'm going to give an overview of what I consider the main challenges in the electric sector, okay, that demand our attention. First one, blockage of migration routes. As we can see that dams interrupt the natural up and down flows of fish, and fish can accumulate in the tailways. We can see here a fish being attracted by the water and jumping, right, trying to go upstream, but with no success. And in this area, they are susceptible to direct impact from the hydropowers. And I will comment this in the next topic. And one solution to reconnect the river is to build fishways. But here you can see a schematic fishway. But this solution is really controversial nowadays. I'm just going to give some aspects of this. We have the dam is a barrier for upstream movement, but also the reservoir is a barrier for downstream movement. Our fish migrate downstream to upstream, but to complete the cycle of eggs and larvae should go downstream. And we're seeing that the reservoir is a big barrier for them, for this movement. I brought this other study here because it summarized relevant and challenging aspects regarding the fishways we have in Brazil. They assessed 80 studies that investigated 25 fishways. And the main conclusions are that the fish passages are high selective for upstream passage. Most facilities do not lead to upstream or downstream sites due to the presence of other dams with no fish passage facilities. So it's the end of the line. They go upstream, but they cannot go further. Evaluations rarely proceed or follow the construction of fish passage, so the efficiency are not well evaluated. And monitoring programs usually neglected important issues like population dynamics, spawning, recruitment, and dispersion. So usually fish passage facilities are not as efficient as they initially proposed. And here we are going to move on to the next topic, that's fish death at hydropower plants. That's another big challenge for us. Unfortunately, fish death often occurs due to the operation and maintenance of hydropower plants. And in addition to ecological impacts, the companies are also subjected to legal sanctions like fines, loss of confidence. They also have conflicts with communities, with stakeholders. So it's a big issue. It's not a simple case. This study was just published last week and shows how the number of fish death events has been increasing over the last 10 years. And most of them are concentrated in Paraná River Basin, where we have lots and lots of hydropower plants. Also in Amazon, that's really important. We have few hydropowers, but with big number of events growing. Well, the main causes of fish death due to hydropower operation and maintenance can be hypoxia or anoxia, gas supersaturation, barotrauma, and fish injuries. But those are physiological causes. At CEMIG, we prefer to refer to the operational procedure causes, because when we identify what operational procedure are leading to a fish death, we can study and identify all the specificities to propose better solutions and mitigate. So here is just an example. We have a schematic power plant in operation. And when the turbine stops running, fish can enter the draft tub, like here. And these fish may die by mechanical shock or decompression, barotrauma, when the turbine starts up. So this would be a cause of fish death, start up. And when we need to dewater the turbine, all this water here need to be removed, and the fish need to be rescued. And this is a really complex and time-consuming process. And if fish are not properly rescued, they may die, usually by hypoxia. So we focus on the origin of the problem, on the operational procedures. Here, the same study I presented earlier shows that hypoxia is one of the main causes of fish death. And we can see that hypoxia is pointed out for fish death events in dams, both downstream and upstream. But mechanical shocks and supersaturation is not so evident in the news, because this was on Google search. But I think this probably is underestimated in reported news, because it's difficult sometimes to identify supersaturation signs in fish, and also mechanical shocks maybe result in not so big events of mortality, and probably not reported on the news. So the path to mitigate the fish death causes, I think it involves a good identification of the problem, its scrutiny, considering all this data, biological, environmental, and operational. It's important to get historical records, to do some monitoring, to understand the ecosystem nearby, the hydropower, establish partnership to do research, because sometimes it's not easy only for the companies to identify the causes. And after that, it will be possible to define action plan and control measure. So here you can see some examples of how to reduce fish death. Sorry, I had to remove some slides explaining how we did it. Otherwise, Paul would never call me again for a seminar. But you can find some examples here in this book. And in this publication that was published in the beginning of this year, we can see some main obstacles to possible solutions in Brazil. And I highlight the limited number of studies on the problem, and the necessity to discuss the problem before implementing the hydropower. This is really important. But it's also worth mentioning that this matter is considered sensitive by the companies. So I think we have much space here to advance in solution. We need to study, but we need the information. We need to know what's happening. We need to understand the problem, right? And discuss some good solutions before the implementation of new hydropowers.
You have 3 minutes left.
Okay. And the last one, change in fish diversity. We can see that damming with build a reservoir changes a lot the ecosystems, right? Both terrestrial and aquatic ecosystem. It's visible. But what happens in the reservoirs and the landilotic stretch between reservoirs? We can see here that many studies point out the loss of biodiversity. And in this study, we saw the reduction of native fish diversity, both in Atlantic, so in the reservoirs and in the lotic stratus between them. And this is a 5 reservoir cascade in Paraná Basin, and we can see also an increase in non-native species, both in lotic and lentic environments. And these changes here was predominantly due to turnover. So we have some species substitutions over the years. Some reservoirs, some studies have pointed out homogenization of fish assemblages, and but also we can see differentiations still happening after 20 years from reservoir formation. And what is really impressive here is that most of those alterations, modifications, are not being monitored. I did a survey in 2018 with some companies from electric sector. I had return from 19 companies that represent 169 reservoirs, and only 83 reservoirs presented were performed fish monitoring, and all of them motivated by environmental license. So it was an obligation to monitor. And to conclude, we saw that Brazil has lots of dams, here, and it's the second country that in numbers of scientific publication dealing with fish under influence of dams. So we have lots of scientific working being done regarding dams, but as you can see on my presentation, I believe that we have a lot to advance. And I hope that by discussing these issues further with this group, we can move in this direction. Okay, thank you very much. Obrigada. Here is the site to download the book that I mentioned.
Brilliant. Thank you so much, Raquel. Your final slide was very useful because we've been having lots of questions in the chat about access to data. Thank you, Rafael, for responding to some of those questions asked by Scott. We've also had Oscar asking, where do you download the Persevivo books? And you've just provided that information in the slide. But I'm sure anybody can contact you if you need any further information. It's really useful. Thank you. Do we have further questions for Raquel? I think we have time for a couple of questions. Okay, I will ask a question. Raquel, I think it's, we've got a question from Hector, but I'll just ask this question first. I think it's really interesting being from a hydropower perspective, but also a fish biologist, because as you mentioned, a lot of these issues are really sensitive. Just how serious do you think hydropower companies are really being genuinely environmentally more sustainable and more fish friendly?
It's difficult. Well, I think that people, environmental analysts that work in those companies, they seek for better solutions to do, to get better with those programs they have. But sometimes we had problems with when the government change, the companies change the way they view environmental problems. So I think it's really challenging because we want to do something, but sometimes we don't have the means inside the companies, you know. So I participate of some groups in the electric sector, that we have environmental analysts that wants to do good stuff, but sometimes they don't have means to do it. So it's difficult.
Thank you, Raquel. One question from Hector, and then one from Andre, and then I will just make a few final comments. Hector.
Okay, and Raquel, which is the expectation from the fishermen about about fisheries? Do they are worried about mortality, diversity, abundance? What do you say about the situation for them?
They are really worried about mortality when these events occur. We can see some mobilizations. They go to environmental agencies. They are really concerned about that. And the other one, fish mortality and?
Yes. Do they are worried about other stuff as diversity or decrease in abundance of some target species?
Yes, mainly migratory.
In general.
They get really worried, mainly migratory species that are the main focus from fisheries. So usually we receive some questions about the reduction of fishes. We need to answer, and sometimes we don't have good answers, right? Good perspective of recovery, fish abundance in reservoirs and rivers. But fishermen are worried, they mobilize, they have some associations to, I don't know in English, sorry. But yes, fishermen.
You can say in Portuguese.
Sim, a gente tem essas associações, né, de pescadores, e eles se preocupam, eles se mobilizam, fazem denúncias junto ao Ministério Público, que é o órgão que corre atrás, né, das empresas para saber o que está acontecendo, para buscar respostas, para fazer autuações quando a empresa é culpada por algum problema de mortalidade, né? Então, a gente vê esse tipo de mobilização, sim, dos pescadores. Thank you, Paul. It's been a while that I not practice my English. Sorry.
You're welcome. So, and we've got one final question, please, from Andre, and then I'll say a few words. But there are other questions in the chat, and I'm sure Raquel will try and answer them at the end of the presentation.
Okay, thank you, Paul. I need to repeat the question that I did to Luz, especially now for Raquel, in terms of the public perspective of the hydropower plants, especially now that we are living a situation where the dry season is making all the reservoir levels very low. The electric bills are getting very high, and the people are trying to sell the idea that the power plants and all the reservoirs is a way to save water and to keep water for the public in general, and to mitigate some of the fluctuations that we have in terms of seasonal changes in water availability and so on and so forth. And that, in my perspective, makes the case that people are more interested to have more dams being built around Brazil, just to give that security that they can supposedly provide. And so how the companies see that moment, and what do you think they are doing in terms of, let's say, surf the wave on terms of trying to convince the public that that's the way to build more dams and to have more water security and forget about the fish?
Well, the solution for accumulate water in reservoirs should be large reservoirs. But nowadays the politics for expansion of electric sector is not to build big reservoirs, only small ones. And our matrix is really getting more diverse with photovoltaic, windy power, and we can see in the energy agency side that the construction of wind power photovoltaic is getting bigger. And I don't know. I think that the solution they see is to accumulate water, to have a way to reserve energy, right? It would be a way, because we still don't have technology and good batteries to almacenate energy. But I don't know if we're going to change this in a short time. I don't think it's possible to change that. I think we are going in the renewable sources and small hydropowers probably, but they do not effective for this energy accumulation. Sorry, my English is terrible.
That's okay.
No, it's
Thank
good.
you.
Thank you so much, Raquel. Some very thought-provoking answers to a number of great questions there. So this really brings the webinar to an end. I hope, like me, you all found it really fascinating. I certainly did. Very informative and interesting. I have some thanks to say. I'd just like to thank all the speakers for taking the time to get their presentations ready. I'd like to thank Hector and Oscar for their help with the collaboration and the setting up of this particular webinar. And I'd like to thank Jenny and Andy for helping also with the administration behind the scenes. Finally, I'd just like to thank all the participants. Please remember that SHAASAN is a network for everybody to be involved in. So if you haven't already registered your interest in being involved in this network, please do so. Please find out more about it on the website. There's a little form there for you to contact us, and then we can register you as an interested participant, and then hopefully see you at the next webinar, which will be sometime later this year in China, and there'll be more information on that soon. So obviously some really huge issues that we need to focus on. Let's see if we can get this transfer of knowledge from region to region so that we can all learn from each other and develop best practice. Thank you, everybody. Have a great day wherever you are in the world.
Bye.
Thank you.
Thanks to you.
I'm going to write my
Thank you so
email
much.
here in the chat so
Thank you so
people
much.
can address the questions.
Bye-bye. Thank you.
Bye-bye. Thank you, Raquel.
Thank you, Hector.
Thank you.